Hello people, welcome back. Today I want to go over C++ templates. So let's say you have a program, say you're building a virtual machine or an interpreter or something like that, and you need to build some functions to add, subtract, multiply, divide. You're going to find out that you'll need to write an add function for every single data type that you have, and that gets very tedious. So what we'd like to do is to avoid having to write all that code over and over again, and that's what C++ templates allow us to do. So first, let's actually take a concrete look at the problem. Let's include IOStream. Use the standard namespace. And let's start by writing a function int add, which takes an a and b integer and returns their sum. Okay, so we've got that. Now say we need to add some doubles together. We'll have to write a function called add, which takes doubles a and b. Okay, that's great. So let's use these functions. Int a, we'll create a number here, int b, use 4, and then we'll print this out. Integer a plus b is add a and b. And then let's create some doubles. Double AA 3.1, double BB is 4.1. And we'll print this out. Double A plus B is add AA and BB. Okay, so now we have a program. Let's try to compile it. Use G++, standard, we use C++ 14 because that's good practice. We'll compile and run, and we get 7 and 7.2. That's great, so everything works like it's supposed to. But this is a lot. Like I said, if you're writing an interpreter or something, you're going to have to write a function for all the signed and unsigned integers, and then the 32 and 64-bit floating points. That's something like 12 or 10 different functions, something like that. That's a lot of functions. That's just for add, and then you'll have to write 10 more functions for subtract and 10 more functions for multiply. So the way that we get around that in C++ is template programming. So we can have a generic type and pass in whatever we want, and the function will be able to take that without complaint. So let's take a look at what templates look like. So let's create a template, and we say type name, and by convention we use T, but it could be Joe or whatever you want. But let's just use T, and our function will return our T type, and it will take in 2 T types, one of A and one of B. And we return A plus B. Okay, so now we only wrote one function instead of 2, or if we had all the different ones, maybe 10 different functions, and we collapsed it down to one that just takes in a generic type, any type that we put in. And so we should be able to run our code the same as before and get the same answer, and we do. Now in C++, I don't know if it's C++ 11, but I know definitely in C++ 14 we have an even better way to do generic programming, and it's using the keyword auto, so we can actually use auto to determine our return type as well as the types of the things that we pass in. Let's do auto A and auto B and return A plus B. So what this does is it looks at, it'll actually automatically determine what the type of A and B is. We don't have to write a template anymore. And so we should be able to still run this code and get the same answer, and we do. And that's great. One thing that auto allows us to do without having to do any more fanciness with templates, say we wanted to pass in an integer here and a double here. A template won't allow us to do that because we only have one type, right? So we're passing in one type, it has to be same type. And with templates, you can actually create multiple templates. So it could have type T and type Z, and we could pass in two different types. But with auto, it allows us to do that automatically. So let's go down here and test that. Let's create a mixed addition where we do A plus B. And let's add an integer A and a double B. Let's see what happens. So we got a 7. Now you might have thought we would have got a 7.1 because we put an integer A, which was 3, and we put a double B, which was 4.1. But we got a 7 instead of 7.1. And the reason for that is the way that auto figures out the return type for the function. To figure out what this function is going to return, it looks at the return statement and sees what the type of the first thing is. So if we pass in an integer for A, it's going to see an integer here, and it says the whole return type of the function will be an integer. If we put in a double first, then it should see a double, and then the whole thing will become a double. So let's try that just to confirm. So let's reverse this. So let's do BB first and then A second. If we compile and run, we see that we get 7.1, and that's because the first number that we passed in was a double. And that's pretty much it for generic programming for right now. There's lots of different things that you can do. You can actually have templated classes and things like that. But this should this is a great way to learn a little bit more about programming. So thanks for watching. Till next time.